Hey guys, and welcome back. Today we are doing a very important lesson about the periodic table. So today we are going to go over how to read the table, what the important groupings of the table are, and it's very important because you guys are going to be using this as a reference pretty much throughout this entire course. So right now I do have our periodic table pulled up. This is going to be a really good resource for you guys throughout this course. This is just ptable.com. So this is our periodic table. You can see this one has a bunch of different colors. It has our elements here. And today I'm going to teach you how these elements are grouped and what it means for them to be in each of their groups today. So I'm just going to come back to our slideshow and jump into it. I just wanted to give you kind of a view of our periodic table before we get started. All right. So we're going to start small and make our way out. So we're going to start with the individual boxes on the table, and then we're going to move to the table itself and how it's organized. So here we have a box that you would see on the periodic table. It's just the elemental box that gives you the information of each element on the table. So this is going to be the information that you can find for each element on the periodic table. So up top we have our atomic number, and remember our atomic number is equal to the number of protons in our atom. Okay, so we do need to remember that our atomic number is equal to our protons. So here for hydrogen, we know that hydrogen atoms have one proton because the atomic number is 1. The elemental symbol just tells us what the symbol is for the element. So here we have hydrogen, its elemental symbol is a capital H. And remember, those elemental symbols will either be one capital letter or a capital letter and a lowercase letter. And then of course we have the name of the element, and we have the atomic weight, also known as the atomic mass. And remember, your atomic mass is the sum of your protons and your neutrons. Because remember, in our atom, the protons and the neutrons both have a weight of 1 AMU. And then the electrons, they're so small, we say that they don't have mass. Okay? So we have to be able to read one of these boxes, especially in tomorrow's lesson when we talk about isotopes. So we just need to know what each thing on the box represents. Okay. So now that we know what the symbols in each box represent, we need to talk about how different groups and different elements are organized in the table. Okay, so here we have metals, nonmetals, and metalloids. Okay, so these are 3 different types of elements that we can find on the table. But we have to group these elements so that we can easily identify them when we're taking a look at our periodic table. So how do we group them? Well, we group them based on association of where they are in the table. And this particular table is based on color. So it's color coded for you so you can tell where each of these elements are. So the blue boxes are going to be metals. The yellow boxes are going to be nonmetals. And then our green boxes are going to be metalloids. And we're going to go over properties of each of these in just a moment. But as you can see, especially with a color-coded table like this, which you guys can reference throughout the course, it's going to be easy to basically just point out an element and determine whether or not it's a metal, a nonmetal, or a metalloid based on its position in the table. So for example, on a quiz or an assignment, if I gave you, let's say, lithium, I said, okay guys, tell me, is lithium a metal, a nonmetal, or a metalloid? Well, the first thing we would do would be to find lithium. So if you're using ptable, you can search it in the bar, or you can just search it on the periodic table. So here's my lithium, okay? Now the lithium is blue, which means it would be a metal, okay? So it's just as easy as identifying where they are in the table. So our metals are on the left, our nonmetals are on the right, and then our metalloids are in the middle. This is called the stair step of the table, and they're in here in between the metals and the nonmetals. Now hydrogen he's special. We haven't talked about valence electrons yet, but there's a reason that hydrogen is in this first group here, but he's actually a nonmetal. So we just have to remember that even though hydrogen is on the left-hand side of the table where the metals are, he is actually a nonmetal. All right, so let's talk about the properties of these different elements. So metals that are on the left-hand side of the table, they are good conductors of heat and electricity. They have high luster, so they're shiny, and they're also ductile and malleable. This means that they can be molded into different shapes. So think about jewelry like silver and gold. It'll mold and keep its shape. And then ductility just means the ability basically to be molded into a wire shape. So think about copper wire. Copper is very ductile and we can turn it into a wire. So the non-metals, those yellow ones that were on the right-hand side of the table, those are poor conductors of heat and electricity. They tend to be dull and brittle, and actually a lot of those exist as gases. So we can, if you think about like hydrogen gas, oxygen gas, colorless, odorless, they're not really going to be conductors of electricity. Now, those green ones that were located in the middle, so on the stair step, those are called metalloids. And they have properties that are similar to metals and non-metals, kind of like Goldilocks, right? Not too big, not too small, kind of in between. Same thing for the metalloids. So they have features that relate to both those metals and non-metals, so you put them in the middle along that stair step. They tend to be mediocre conductors of electricity, so we call those semiconductors. So they can conduct electricity, but not as much as a true metal would be able to. Okay. So first thing we need to know, metals on the left, non-metals on the right, and then along that stair step, we have those metalloids. Okay. So now let's talk about how we can basically figure out where an element is in its period versus its group, okay? So periods are going to be the horizontal row in the periodic table, okay? That's why we call it a periodic table, because it's organized periodically, right? So periods go from left to right, and they're just numbered 1 through whatever. So 1, 2, 3, 4, 5, 6 as you go down, okay? So period 1 would be the first row, period 2 would be the second row, so on and so forth. Now, the way that I can remember this is that periods go at the end of a sentence, okay? So when you write from left to right, you write a sentence and then you dot it with a period, right? So left to right, period, left to right, period. And that helps me remember that these horizontal rows, those are the periods because you put a period at the end of a sentence, and that just helps me. So moving left to right, we have our periods. So for example, if I asked you to, give me an example of an element in period 3, you would just count down 1, 2, 3, and any of these yellow elements, those would be in period 3. Okay, so you just have to be able to locate them based on the period that they're in the table. All right, now let's talk about groups and families. So the vertical columns that go up and down, those are going to be your groups or your families. You can call it either way. So the groups and the families, these are special because the elements in the group or the family have similar chemical property. And the way that you can remember this is that think about yourself in your own family, right? So unless you were adopted, genetically, you share genes with everyone in your family. So if you have siblings or parents, you have similar genes. You're each different and your own individual, but you do have similar traits because you share genes in the same family. It's the same thing with these elements. So if they're in a family, so again in that vertical row or that vertical column, they're going to have similar chemical properties. Okay, so periods from left to right, groups or families up and down. Okay, now I will say the numbering for the groups and the families are the same. So it would be group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so they are just numbered 1 through 18. However, they also have a special numbering based on something called valence electrons, which we'll get to a little bit later, where you basically skip these in the middle. These are called transition metals. And so it would be 1, 2, skip these, and then 3, 4, 5, 6, 7, 8. So you could see it both ways, and we'll talk about it a little bit more in depth later. But for now, we just need to know that the groups and the families, they go up and down, and they have similar chemical properties. Okay. Now, these groups and families have special names. Okay, so let's go ahead and talk about these names. So group 1 is called the alkali metals. So any of these elements in group 1 would be classified as an alkali metal. The elements in group 2 are the alkaline earth metals. These blue metals in the middle, these are called transition metals. Okay, and these are a little bit special, so we'll talk about them a little bit later. Here we have our boron group, then our carbon group, our nitrogen group, our chalcogens, our halogens, and then finally our noble gases. Okay, so again, these different elements in these groups are going to have similar properties. For now, because we're just learning the table, your job is to be able to identify what group each element would be in. So for example, if I said, okay, we have, let's say fluorine. Fluorine's right here. If I gave you guys fluorine and I asked you to tell me what group it's in, you would just have to be able to tell me, oh, fluorine is in the halogen group. Okay, so what I'm asking you to do is be able to identify the period and the group. So like fluorine, for example, it would be in period 2 and it would be in the halogen group. Okay, so it would be in the halogen group and it would be in period 2, okay, because it's in that second row. So that's really all we're doing right now. And then on the bottom we have our lanthanoids and our actinoids. These are pulled out of the table because it just makes it a little bit easier for us to fit it all on one page. But if you guys see here, the 57 through 71 and the 89 through 103, those are where these would go, right? So if we extended this table out, basically these would be cut and paste into these positions right here, okay? So the representative elements or the main group elements are the A groups, and then the transition elements are in the B group. So the transition metals, those blue ones that were in the middle right here, these are going to be our B group elements, and then our A group elements are going to be 1, 2, 3A, 4A, 5A, 6A, 7A, 8A. And then those inner transition elements are found below the main body of the periodic table, and they're also referred to as the rare earth elements. So again, that's the lanthanoids and the actinoids. So these are your rare earth elements down here on the bottom. And then here is just a picture, another periodic table that shows you that different numbering of the groups. So remember, I said that there's 2 different ways to number it. The number on the top of the groups, that's just the 1 through 18. So it's just labeled 1 through 18. And then they also have their A and B group labeling. So 1A, 2A. Then down here we have our transitions, and these are the B groups. So that's why you see it as 3B, 4B, 5B, 6B, 7B, etc. And then again, on the right-hand side, we have our A groups. So we're going to go from 1 to 3A, 4A, 5A, 6A, 7A, and 8A. Really, all you're doing is dropping the 1. Okay, so like 13 is 3A. Okay, and that will help us when we talk about valence electrons too. But for now, all we need to know is that there is an A and a B numbering. And it can be a little bit tricky to know, if you have a question, whether it's talking about A or B. But it's pretty easy to figure it out because it's kind of a process of elimination. Okay. And that is it for just the rundown of the periodic table. You guys have a scavenger hunt that you're going to do today. If you have questions on any of the numbering or the difference between the periods and the columns, let me know. But if not, you guys are good to move on and start working. Hope you guys have a great day, and I will catch you in the next one. Bye, guys.